But so yeah, so trying to understand what causes rotational motion um, from yesterday's experiment, thinking through yesterday's experiment, there are suggestions from Seth and Pratyush suggesting that a variation of the same thing, saying the distance. I'm combining both of what Seth said and Pratyush said and correcting one thing in each of their explanations. So Seth said distance from axis of rotation times he said mass is not a force, and Pratyush said force. So, but Pratyush just wrote distance, so he didn't write distance from axis of rotation. So this is um, uh, set plus Pratyush hypothesis. Okay, by the set Pratyush hypothesis, we can put it like that. So the force, of course, in this case would be uh, the mass times the gravitational attraction for that object, for that 50-gram mass. So there will be a force acting this way. And then in the case of this stone, so I'll have to put, let me just change that a bit. The mass of the slotted weight times the gravity, and in this side it will be the mass of the stone times gravity. Okay, so these are the forces that are involved, right? And since we figured out that the earlier hypothesis that we had about the mass on this side, the mass of the weight plus the mass of the scale and the negligible mass of the string on that side, and the mass of the stone plus the mass of the scale on this side are balanced, and that is why you have equilibrium. Okay, that's why you have static equilibrium. And we figured out pretty quickly that that's not the case, that cannot be the case, because if we shift the masses, if we either bring this in or out or bring this in or out while keeping one of them stationary, then we have a peculiar situation in which the equilibrium is broken. So you can easily imagine that there will be an either clockwise rotation or there will be an anti-clockwise rotation. So therefore, we have to refine the theory, and therefore we come up with this. So what we mean by this is that it's not just the forces, it's also the distance between the forces and the axis of rotation. So this distance, which let's say we can call the distance on the what's that, clockwise side. How can we uniquely define it? The distance on the, I guess we can use our lever studies machines, and we can say that this is the effort side. Shall we put that? Is that okay? Is it unambiguous? Or shall I just put SW, the distance on the slotted weight side? I'll just go with that. I'll put the distance of the slotted weight side, and then on the other side you will have the distance of the stone. Okay, so now does it seem like a complete theory? Now does it seem like that can explain everything that we have to ask about it? What do you think? Slotted weight. Yeah. Okay. We don't need to consider the length of the string, the mass of the string as being contributory. They do contribute, but we assume that the lengths are the same, so they contribute equal to both sides. And Kabir agrees that we should call it the slotted weight distance, just to be unambiguous. But of course, he misspelled it and wrote spotted weight distance, unless you meant that its weights are spotted. Okay, so I'll just give you a moment to digest it. I've forgotten to shut the door and there are noises coming from outside. I'll just shut it and come. Hold on for a minute, please. So now to move forward, um, what we can therefore say is that, and this can be seemingly a little complicated, but I'll just put it out here. It's not really something that you need at class 8 level or class 9 level also, but this is a concept that we will revisit again when we come to class 10. In fact, this particular experiment with the scale and the sorted weight finding out the unknown mass is a standard experiment that we give in class 10 for the board examination. So you will actually perform these experiments. I'm just giving you a kind of an insight into it at this level, and we will study it again later. So don't really worry about it too much if you didn't get it. So therefore, what I can now say, to look at this situation, to look at the fact that there is static equilibrium, what I can say is I can equate uh, the anti-clockwise uh, force. Okay, so I can say that the uh, anti-clockwise force. So I'll write force, but obviously that's not correct, right? Because the force by itself does not define the fact, does not expand the fact that it is not just the force, it's the force multiplied by the distance from the axis of rotation as per the set Pratyush hypothesis. So
Sir, can
therefore,
you please check the chat?
can I please check the chat? Sure, I'll do that. COG. Yeah, we will discuss that situation when the center of gravity of the scale to bring the slotted weight at the. You mean push the slotted weight all the way is here? Yeah, okay, we'll come to that. We'll come to that. Once I have given the equation, then you can do all that. You can look at the various situations. All right. So Set is asking, what if we were to bring the slotted weights at the COG, the center of gravity of the scale? Okay, but we haven't discussed the concept of center of gravity yet. So I really won't go into that at the moment, but I'll give you an equation that can help you mathematically analyze, quantitatively analyze what will actually happen. Okay, so we'll have to wait for that, because the next concept that we are going to deal with is, of course, center of gravity. Okay, we need to look into that too. But right now, all I'm saying is, if I were to expand this sigma f is equal to 0, the static equilibrium situation, then I have to show that the forces acting this way are equal to the forces acting that way. But I can't use the word forces, because it's not just the forces, it's forces multiplied by a distance. Okay, so therefore we need a better word, or we need a different word, and the word that we use in physics is the word moment. Okay, so I'm defining a new word, moment, which is the force, okay, multiplied by the distance to axis of rotation. So axis of AOR, I'm putting it as axis of rotation as AOR. Even this is not quite kosher. I'd like to demonstrate that a little bit, why it's not just the force multiplied by the distance to the axis of rotation, but for the moment I'll just keep it as it is. So for the static equilibrium to be true, I have to say that the anti-clockwise moment, that all the forces acting to cause the anti-clockwise rotation multiplied by the distance from the force to the axis of rotation, should be equal to the clockwise moments. Would you agree with that? Okay, seems logical, seems rational, seems sane. So now to expand on that statement itself, what does it mean is that all the forces multiplied by their distances to the axis of rotation, which are causing the anti-clockwise rotation, is equal to all the forces. Why I'm saying all the forces? Because it is not necessary there are only one forces on each side, right? There can be a system of forces on each side. So in our case, we use the simplest explanation possible. We use the simplest situation possible and say one force on each side. So therefore I say that all the forces that are causing this multiplied by their individual distances to the axis of rotation are equal to each other. So therefore in our case we can write what are the forces that are causing clockwise moment. It is the mass of stone times g. Okay, so this is the force multiplied by the distance of the stone. Okay, please let me know if you don't understand any of the abbreviations over here. Okay, and in this side it will be the mass of the slotted weight times the gravitational constant multiplied by the distance of the slotted weight. So now I have an equation, okay, which describes in the most general form possible what is happening in when this situation hits static equilibrium. Okay, so now if I have been given, right, some of the quantities, right, what are the quantities that I am aware of or I can measure experimentally, is that our subtask, our experimental task was to find out the mass of the stone, correct? So that's an unknown to us. So the mass of the stone is an unknown. What are we aware of? What are the things that we know about or we can measure? The distance of the stone to the axis of rotation we can measure. That is the reason why we use a meter rule. So you actually suspend these two things, you can actually measure off the distance over there. The mass of the slotted weight is given. We said it was 50 grams. I'm not talking about the gravitational constant because it's obviously a given, but then it's somebody who knows or can look at the mathematics, tell me why the gravitational constant is not important in this case, in this particular case. Okay, so I'm going to leave that for somebody to answer. What about these? I'm asking you. Okay, and the distance of the slotted weight, which can again be measured off the scale. So you have one unknown, right, and three knowns, except nobody has yet answered why G is not important. No reply to that?
I think you can cancel G's from both sides, so it's not important.
Yeah, yeah, thanks, Ratul. So the reason why G doesn't really matter is because there's one G on either side of the equation. They are all products, right? So therefore, you can just leave G out of the equation because it really doesn't matter. The gravitational constant is the same on both sides. You're not comparing something in Earth to something in Jupiter, so it doesn't matter. The gravitational constant is the same. So for all intents and purposes, we can actually leave out the gravitational constant. And then using this equation, now you got to make the mass of the stone is the subject of the equation, and you have the answer will pop out from what you know. Okay, so from unknown to everyone, who's this unknown? Yeah, I'm sorry. We had a drop in the internet connection and then it's back. So this happens once in a while. Okay, so to dive straight back into it. So therefore, with this equation, we will be able to determine the unknown mass of the stone when you are given a meter rule and a known mass. Okay, by suspending them, you can get the answer. And now to go back to Seth's question, so now you can see, Seth, if you move the slotted weight to the point where the scale has been suspended, then you see the distance of the slotted weight reduces to 0. Okay, so that means that the distance of the slotted weight reduces to 0. So then you are not going to have an equation, you are going to have an inequality. So therefore you can immediately see that the situation will then become it will become a non-equilibrium situation. So therefore, there will be some residual anti-clockwise moment, and therefore the system will start rotating in an anti-clockwise direction. Yeah, yeah, no clockwise moment. So the some unknown is saying so no moment, but you should be more specific. There will be no clockwise moment. There will be anti-clockwise moment, and therefore the object will rotate in the anti-clockwise direction. Okay, I just want this unknown to um, identify itself. Who is unknown? I don't know, when I was admitting people in, I didn't check.
Check the chat, sir. Say it.
What? It's set?
Unknown is say it.
Unknown is set. Okay.
Yes.
All right, fine, no problem. Uh, so now we should really move on from this and look at the next situation that is possible. What was that? Okay, so the next thing that I want to pick up is the following. So I'm giving a situation again. That's a rigid object, side of a rigid object, and there is a hinge. Okay, I'll explain this again, of course. And there is a door. Okay, so all this is viewed from the top. So that's the door knob. Okay, so rigid support, hinge. You know what's a hinge, right? Something that allows an object to swing. So you do have those in doors and windows. Okay. And this is the door now. It can be a door or a window, and this is of course looked at from the top. So if you want to open or close the door, you apply a force in this direction. Let's say you want to open the door in this direction, which will be anti-clockwise. Okay, so then you apply a force in this direction. All right. Yeah, so Deeta is just asking me something about the YouTube link. I sent it to your email IDs, the link to my YouTube channel. So just check your email from about a couple of days back. When I sent the videos for the rotational motion thing, also the experiment result, so it was there in that. So just check your email. If you can't find it, send me an email. I'll resend it to you. Okay. And so coming back to the problem, so the force is applied there. The axis of rotation is over here. It's through this hinge over here. Okay, so it's coming out like this towards the camera, out of the whiteboard. And therefore, you can say that the moment of force about the axis. This is just the terminology that they use. Okay, so the moment of force about the axis. So the force multiplied by the distance to the axis can be given as F multiplied by this distance. Right? The distance between these two. distance. Okay, right now there are no two moments that we are talking about, so I'm just going to keep the d as the distance. So I can say that it is F multiplied by d. Okay, so that is what is causing the force. Incidentally, this moment of force about the axis is given the term torque. Okay, so torque therefore is equal to F times d. Torque is abbreviated to the Greek letter tau. As in Tauji. Who is a Tau? Tauji is an uncle, right? Yeah, so Tauji. So tau is equal to F times d. So now Manya wants to know. Manya, if you have a question, send it to the whole group, okay, so that everybody can see it. So we are kind of running out of time now. We have a little under 2 minutes left. So when the meeting gets over, I'll re-log in. So please rejoin the meeting as soon as you can, and then we will continue from there. Father's elder brother is tau. Yeah, so this is tau g. So tau g is equal to F times d. So Manya wants to know why this distance is taken. Well, what I did was I took the point of application of the force, the line of application of the force, and the distance to the hinge. So what do you think should be the distance? Yeah, it's just an extra fancy P, that's all. That's right. So Manya is having some difficulty accepting the D as the distance, and that's good. So now what should be the distance then? Yeah, it's like a lever. That's right. But I'm just checking with Manya if it's okay for me to carry on from this, or she would like me to explain something before I move on. Manya, answer to everybody in the group, please. Don't send private messages. Okay. So I'm just saying that it's what, in fact, that's very good that you asked. What I can say is, what should I keep as the distance? Okay. So will you say that, okay, the point of application of the force, so should I, to the axis of rotation, to the actual axis of rotation, should I keep that as the distance then? Okay. Right now I gave the simplest possibility, which is